we'll need to do it a little manual because it's still in the internal approval process. Okay, so we are going to together actually architect a dynamic internal developer platform. And so first of all, I want to quickly speak about the making of this reference architectures, what problems we aim to solve, the design principles that we applied, and we're going to go to the actual design, and then I'm going to like a dry run walkthrough if you want. And I've asked for PlatformCon, for our last conference, we're expecting up to 20,000 people this year. I've really asked all the speakers, hey, please focus on reference architecture. So I hope there are a lot more reference architectures coming. We had 500 proposals for talks. I think we accepted 100, so super excited about that. Make sure you have a look at this as well. So again, I talked about that. McKinsey is working on this, starting with Amazon, and then we have a lot of others coming. But there are a lot of different enterprises and actual platforms that we looked at for that, and we've used common patterns. And I think it's worth noticing that we have like a size bias, right? So those architectures are designed for teams with up to not up to thousands of users, but from minimum 50 users, rather 100 users onwards. So if you're like a cool startup and you're just starting off and you're fresh and standardization doesn't matter, please use Vercel or Heroku. But other than that, this is actually, I think, something pretty cool. Okay, let's go ahead. What are the problems that we wanted to solve? The usual things that why we're doing platform engineering. We have long lead times. It just takes too long. Time to market. We're in a recession. It needs to go faster. Otherwise, executives are sad, and then we have too much ticket ops, and we have high cost of maintenance, and we have overwhelmed developers, and we have waiting times, and we have missing self-service. And that's because our setup is unstructured. It's because we have too many versions of Postgres, and we need to maintain them, and we have too many files here and too many Terraform files, and the communication doesn't work, all of these things. And now we want to get into a situation with low lead time. We want to have a high degree of standardization. I cannot say that enough. That's the key thing here. We need to design systems. We're going to get into the design principles that drive standardization by design. We want to have, to a certain degree, and many people have crucified me for this, but we want to have a certain degree of separation of concern. Yes, ownership of the services. Yes, to a certain degree, you build it, you run it. But separation of concern is nothing to be afraid of. Abstractions are nothing to be afraid of as long as you don't take context. And then we want to have self-service, and that is another principle here. Okay. Yeah, exactly. And so the sequencing, if you want, and it took me a while to understand this. You want to be able to dynamically generate configurations. We want to have, however you do this, but we want to have, and I'm going to explain what that means, a design that is able to dynamically generate application and infrastructure configurations with every deployment, because that drives standardization by design. By doing this, we enable all of these things: self-service, eliminate ticket ops, golden paths. And I'm going to be very concrete. It's another little bit of buzzwords, but I'm going to be very concrete. And because of this, we are slashing lead time. So this is actually sort of the logical thing here. I want to make sure that we give the right people credit, because I didn't code this. This has been done by Stefan Schneider, Mike Gatto, and Marco Marulli, and I think we'll hear a lot more from them. I wanted to insert photos, but I didn't find good photos. So we'll probably do that, hopefully, when we send this out. What is a reference architecture? First of all, those are standard patterns on how to combine frequently used tools and design choices. We'll have them as visual flow diagrams, and you're going to see that now. We have that packaged as code. That's an open sourcing. We have white papers on this. We can share that. And then we are going to have, we don't have that yet, tutorials on how to actually interact with them. And we're going to do a lot of this. Cool. What are the design principles that we've applied? Number one, golden paths over cages. What does that mean? It means very concretely, follow this platform, use this. If you use this, you get certain guarantees. If you want to go off the golden path, please do so. Opaque abstractions, we don't force anybody. You can do whatever you want. You can go down to the lowest level, but then, my friend, you're on your own. Second, we want to have standardization by design. What does that concretely mean? By using the system to deploy and deliver your application, we are keeping the degree of standardization as is, or we are improving it. By deploying more, by adding more services, we are not making it more complex. And that's a very, very, very difficult thing to achieve. But that's what we've tried to apply here. Possible through dynamic over static configurations. That means rather than having, I don't know, Terraform Helm combinations that you need to maintain, and they're really clean at day zero because you fork something from a service catalog, but then they start derailing through the lifetime of the application, through the environments. Rather than that, we treat every day like day zero. If there's anything I want you to take away, treat every day like day zero, regenerate app and infrastructure configurations with every single deployment. And then we want to have code first. Very important. Modern enterprise, we want to make sure that we have disaster recovery. We want to make sure everything is as code, and we never break the workload of the developer. Where is the developer in code? And it doesn't mean you can't put a user interface on top. We're going to have that as well. And you can do all sorts of fancy things and CLIs and yada, yada, yada. And I even advocate for leaving interface choice, but the code needs to be the single source of truth. Okay, cool. So that's it, right? This is the reference architecture. This is lots of logos. Let me say one first thing. You can interchange all of the logos. You can use different CI pipelines. You can use 5 different CI providers. You can use 3 different registry providers. You can use different orchestrators, different resource plans. It doesn't matter. That logical design is all the same. And we have 5 layers. And for me, this was also McKinsey's proposal. So I'm piggybacking on their fame, but they dissected this into 5 different control plane layers. You have the developer control plane layer, which is the interaction between the developers and platform engineers and everybody with the platform. You have the integration delivery plane. You have the resource plane. You have the monitoring plane, and you have the security plane. And what I want to do right now is I want to go through the different planes, explain what they are, explain the design choice, and then what we're going to do as in the next step, we are actually going to follow a simple deployment, because the unit of change in this platform is the deployment. So all of these activities always happen at deployment time. That's our pulse of business, if you want. That's exactly what we're going to do here. Let's sort of a couple of observations. We've in this reference architecture chose Backstage as a portal because it's the most commonly used. There's another one coming with GCP, and that's using Atlassian Compass, which I think is sort of the second big player in that portal space. Not many know it yet, but we're seeing it in more and more cases, and it's accelerating really fast. And if you're in the Atlassian ecosystem, I'm personally a big fan. Then we have obviously version control. We're using SCORE as a workload specification. In this case, infrastructure as code with Terraform, but you could swap that logo with Crossplane or Pulumi or whatever. We have GitHub Actions here, Amazon ECR, Humanitec as a platform orchestrator. This is, I think, a little misleading. The actual implementation, we're using ArgoCD, which is the commonly used and has much more beef. And then you have the resource plane layer here. And this, I think, I've seen a version with Datadog, very helpful. And this is HashiCorp Cloud Vault, again, the usual suspects. Cool. Now, let's actually get cracking and dissect this. So, developer control plane level. We looked at this already a little bit. Obviously, let's zoom in. And the first thing that I want to zoom into, the thing that not everybody's using yet, is this is a little here. Let's start with this first, the workload specification. And the workload specification, what is that actually? It's a general recipe on how my workload relates to dependent resources. If you want, it's a general way of explaining my architecture to a system. And I'm explaining this in an environment agnostic way, which means that the description is, it doesn't matter whether it's staging or production. In any case, in this example, Python service depends on a resource of database Postgres, storage S3, and then a type DNS. And then we have a connection string that tells my workload how to connect to my database. And this is actually how the SCORE file looks. So it's not, I'm depending on that particular RDS database. No, we're saying I'm depending on a database of type Postgres. Now, there is exactly one score file, one workload specification, and you can use score, you can use anything else. That sort of doesn't matter. We're using score because, it's the open source project I worked on, so I'm in love with it. But you know what, you can write your own. Many enterprises have their own version of this. You have one of those workload specifications, and they sit next to your workload source code. You then localize them on an environment by environment basis. So that's the workload specification. This is where, if you want, the developer with every single deployment orders what they need. Okay. And then the other interfaces are used in different situations. So, and I listed this, and we're going to send it over, but let's actually have a look at, and this is not data driven. I've jotted my observations down. I would have loved to give you, this is against 1,000 people, but that's really just what I'm observing. So usually for deployment, you have your Git push flow, right? Terminal, IDE. Then for configurations and change to configurations, you have the workload specification. Same thing if you want to add and remove a resource. And that's already like a hint. Now you can actually add a resource by just saying, hey, I'm adding another resource definition to the workload specification. You can do that on the go. And by just doing a Git push, it will create that resource and wire this up. Promote this to the next environment, and it will do that in the next environment. So that's the beauty here. So this is what we're using for removing resources. Then for rollbacks and diffs, because we have that single source of truth, we would probably use an API CLI UI, resource detail configuration. So how is the config of the S3 bucket actually looking? Definitely infrastructure as code, predominant method still Terraform. Spinning up a new environment, by definition, if every day is day 0, you can also do that. That's definitely API CLI or UI. Same for logs, although that would probably be aggregated as the portal layer. I don't think that this is so correct. Then the portal, the service catalog, you would use that if you want to, search what microservices we already have. We have an inner source use case. Has this been done before? Definitely portal. And we have a service create, like a scaffolding case, right? So this is usually the portal in combination with the templating API of something like GitHub or GitLab. So those are the interfaces. And so the answer, it depends what the user is using. And the answer is, hey, different users, different choices. If you have a couple of dozen developers, some developers like the CLI, some developers like to use the code base. And I'm a big fan, if you really want to drive adoption, the systems should be designed in a way that they can actually choose this. Cool. So this is our developer control plane layer. The next element is the integration and delivery plane. And a number of these things are obviously familiar. We have our CI pipeline building the code, and then we need to push the code somewhere. And in that case, it's a registry, and I'm using ECR here. It could be any other. And then we have the orchestrator component. And the orchestrator is basically a configuration file generator, like a smart config file generator with sophisticated RBAC functionality, could deploy, could orchestrate infrastructure, but could also just call other APIs, like call Terraform Enterprise, call, I don't know, hand over to ArgoCD, whatever. But the job of the orchestrator is to read that score file and say, hey, okay, well, where are you deploying to? Environment of type staging. Well, perfect. Let me dig up what database to wire you or what to create for you. Create the app configs, pull the secrets, and then actually hand over to deploy itself. So that's the integration and delivery plane. Let's go to the next element, the resource control plane. Also comparably straightforward. What we have here, those are the infrastructure components you're using today. In this example, so out of the box, this platform as code, just to give you a couple of examples, is spinning up an EKS cluster, and then you can order namespaces or whatever. You have RDS as a database, Route 53, Amazon SQS, but the design of this architecture allows you to really genuinely use whatever you want. You can use, you can have your Postgres running on a VM in a basement of your grandmother that you've never looked at in ages, and you can wire this up. Anything that can, construct a, has an API basically is something you can wire here. So that's the resource control plane. And because we are applying dynamic configuration management, it's totally possible to have many cloud estates. So Another thing that's coming out is this in a multi-cloud example. Multi-cloud or multi-cluster in this case doesn't really, is that much of a difference then. Because the actual configurations are created with every deployment, the configurations are created against the target environment. So that means if you're deploying to Amazon or you're deploying to Google, it doesn't matter that much because that's going to be localized. And what this also supports is fairly complicated resource combination orchestration, if you want. So let's say, give you an example, the developer in the score file says, hey, I need DNS. Well, what that actually means in the real world is, yeah, you need DNS. You probably also need a certificate issued, right? And you need ingress. And that means that simple request DNS, if we would just translate that, that wouldn't be enough. So we that would actually create a cyclic resource graph and sequence the creation of these elements. So they're actually ready in combination, which also allows you to then QA this better and operate against this more sustainably and at scale. So that's the resource control plane here. Then we have the monitoring and logging plane. And here, this is too simple. So actually, if I have a couple of areas where I think we need to improve this, that's definitely the monitoring and logging plane. Because the reality is you have APM, right? You want to see what's going on my infrastructure. You have a whole topic around error messaging. So how do you surface errors from different infrastructure components centrally? You have a whole conversation around how do you stream centralize the elements of the outputs of the workflow. How is CD performing? Are there any sign-offs that need to happen? All of these things need to actually be aggregated, and that's a pretty non-trivial task. So actually here you need more, and then you probably want to aggregate that on an orchestrator API level or on a portal level, so that's actually easier to consume for the user. So that's the monitoring and logging plane, but pretty much you want to have the observability tied in. You probably, if you're creating the app configs with every single deployment, you can enforce the use of sidecars, labels and annotations, make sure that you really have good coverage here, and make sure you can actually centrally pull in all the logs on a workload by workload basis and really see what's going on. So that's here the monitoring and logging plane. And then there's the next element where I think real life is a lot more complex. The security plane, now secrets management with Vault, but then, we often have policy systems, compliance-based translator elements that say, well, in this situation, you need to create a ticket and it needs to be approved and it goes into production. So I think all of those things also need to find their way in. So this is heavily simplified, but a good starting point, I think. Yeah, so now those are all of these different elements. And now what I actually want to do, let's quickly go back to our beautiful overview graphic here. I want to actually follow a deployment, our unit, our rhythm of business, all the way from the Git push down to the running application, to the configured resources. And before we do that, I want you to understand that, again, that idea of dynamic configuration management. And 9 out of 10 people, when they say, yeah, I get dynamic configuration management now, don't really get it, because it's very different to the approach that we've been approaching for a good decade or so. So let's go through this again. I think about dynamic configuration management as an asynchronous love affair between platform engineering and application developers, which is such an unsatisfying experience, right? Having an asynchronous love affair. But that's really what it is. So you have that abstract description of the world. Hey, I'm a developer. I have a workload. It depends on a database of type Postgres. I'm describing what I need. Now, I'm sending that through my CI pipeline. And by doing that, by definition, I'm indicating a context, otherwise that couldn't build. So it's a tag, and then I have a matching criteria. I'm deploying to an environment of type staging. I'm deploying to an environment of type production. This is an ephemeral environment. I have an app ID. I have a test ID. I have an env ID. I mean, you get the drill. So there's some sort of indication of context. How we're doing the indication, subject to the specific respective organization and whatever, but we have a context. Now, I'm sending the context, it's making its way through CI, and I would do that if I've applied a change to a workload source code. And with every deployment, I've used that sentence a lot, but it's also very important. With every deployment, the score file is making its way through my CI pipeline, and it hits the orchestrator. And now the orchestrator is performing an RMCD execution pattern. And it's called RMCD because of the song YMCA. That's actually the only reason, because YMCA, you'll always remember this, and then you think about RMCD, and it's easy to remember, and you have the tunes in your ears. And RMCD means read, match, create, deploy. I'm reading the file, and the orchestrator says, oh, there is a file. And because we treat every day like day zero, the orchestrator has no prejudice. So the orchestrator thinks, let me read that file and figure out what that workload needs. And reads the file, figures out, oh, needs a Postgres, needs a DNS, needs an S3. Okay, fine. Now, next step, read, match. What's the context? And the orchestrator again looks at the metadata and says, oh, yeah, this is an environment this is a deployment to an environment of type staging. Well, let me make a look up what the platform engineering team wants me to use in that circumstance. Now, let's say in that case, we say, oh, this is just a deployment to development. I just want you to use there is already like a Postgres database, and I don't want you to create a new one. I just want you to route to the existing one. Okay, says the orchestrator, I'm going to go over to the next stage, the create stage. In the create stage, we're going to say, okay, we'll create application and application configurations by applying that workload to baseline configs. Think of them like empty Helm charts. And then we are actually going to create or wire existing infrastructure components. In the very trivial case, we'll just reach out to the Amazon API and fetch the latest credentials, and then inject them through secrets at runtime into the container. Or in the more complex case, we're going to do advanced cyclic resource graphs, and we'll do all sorts of procedures in the background, and then we'll route everything up. Now, then there's the deployment stage. At the deployment stage, we again have, you guessed it, code files. And those code files can sit in a repository, and then something like Argo can take over, or we're handing over to other orchestration things, or your orchestrator can do that in-house if you want. That depends on the systems you're using. But in the end, that's what we have. Every single deployment, we are dynamically regenerating configurations, and we have that hot, juicy, asynchronous love affair between platform engineering and application developers. Good. And what we're going to do now is, and that's like a world premiere, we are actually going to look at a golden path. So a golden path is something that the developers can use. And if they stay on this, they get certain guarantees. And I want to show you the first golden path now. And it's a golden path that's so trivial, you'll think, what the fuck, Kaspar? My GitHub Actions can do that today. What are you talking about? It's deployment to development. Nothing is special about deploying to development, really, like nothing. But by taking the most trivial case, you'll get an understanding on how this actually works and pans out, and you will understand, even in that trivial case, what is the beauty of standardization by design. Okay, so we're deploying to development. We've applied a change to our little Python service, nothing special. Git push, let's let it run. Our workload specification also runs because it's always being sent. And we now have the context. The context, environment equals development. Environment type actually equals development. And then we are going to hit, at some point, the orchestrator component. And the orchestrator is singing its tune, read, match, create, deploy, RMCD. It's reading this, it's matching the context, it's creating the configs, it's configuring the resources. In this case, it's really just reaching out because the resources are already there. and then it's deploying, and we have our clusters configured, and everything is wired, and everybody's happy. Now, again, you're looking at this and saying, okay, well, great, whatever, you have a deployment to development, congratulations. Well, the thing is, while this is the case, there are like a ton of things that could have changed under the hood. Let me give you a couple of examples. You might have changed the labels and annotations that you want in workloads, right? You might want a different sidecar. You might want to update Postgres version 14 to Postgres version 15. You have different, I can give you like hundreds of examples. Now, in the normal world, you would send out a request to all developers, can you please update that? And then after a week, you would do this again and nobody does it. And then after 4 weeks, you ask your CTO to send the email. Like, we've all done that a couple of times. Now, in this world, all you change is the baseline configuration. And then with the next deployment, these things are dynamically flowing in. Standardization by design. By just using the system, it is standardizing itself. So that's the beauty. And now, because we are dynamically creating stuff, we can actually take this to the next level, and we can go into the scaffolding workflows, and we can go into the creation of a new environment, for instance. And let's actually do this. And this is my golden path scenario number 2. We want to create a new environment. And what's the developer experience? Incredibly simple. We take the exact same score file, we take the exact same code, and the only thing we change is that we indicate a new context. And the context in this case is, hey, this is an environment of type ephemeral. It hits the orchestrator says RMCD, exactly, read match, hey, environment equals ephemeral. All right, well, now I'm going to create a Postgres, I'm going to create an S3 bucket, I'm going to create a DNS. Wait a minute, DNS, we need ingress and certificate. Oh, cool, I can do that as well. I'll use Terraform or Crossplane, or I will automatically send an SMS to the Vatican and the Pope will do it himself and then send back the credentials. It doesn't really matter. We do that. And then we create the application configurations. We receive the credentials, secrets, we wire everything up, and then it's deployed. And we have a new namespace, we have RDS, S3, DNS, everything is in the latest state. Okay, that's the second golden path. And this also means, well, it doesn't matter whether this is the first time or the 10th time. This could be a scaffolding. This could be after 2 years that this application exists. And this is running through completely automated and making sure everything is tidy and clean. Cool. Next example here is just for the sake of it, deployment to production. What's the message I want to send? The message I want to send is the exact same thing, indicate context, and then we have everything running. The more important example is what happens if you want to go off the golden path. I'm always, another nice buzzword that I'm always saying is golden paths, not cages. So how do you ensure that this isn't a golden cage, right? Because I mean, these things are great, but there's always that situation where you need a resource and the platform engineering team hasn't provided it yet. And that's a very, very frustrating experience for the user, because now you have the feeling, oh, I've been restricted and I have to wait for another team. And how is this better than what I have today? And the wonderful thing here is you can give an answer to that. And the answer is going off the golden path. I will use the example of ArgoDB, which I'm always using because ArgoDB is something you never need until you need it. And so then you say, well, I need ArgoDB, and you're sending the request to the orchestrator, and maybe that has dry run functionality, and it's returning, hey, ArgoDB, I don't know that. I have no idea what to do. So, in most cases, you would be stuck. Now, not in this case. You can actually teach the system how to create ArgoDB, right? And that is also what I mean by layered abstractions. Assuming the developer has the role-based access control to do so, they can now go in and actually define how ArgoDB is set up. That resource knowledge graph, if you want, can actually learn decentrally. And this is leading to something that was a revelation for me 2 weeks ago, that if you want platform engineering, good platform engineering is actually about cutting and designing your repositories in a sustainable way. It was mind-blowing for me when I first heard that. But that actually, there's a lot of truth to this. We're going to look at this in a second. And so that's exactly what you can do here. Hey, you're just teaching that system. Well, by the way, this is how you create a ArgoDB. And in those situations, if those matching criteria are met, should you actually be using a ArgoDB? All right, so again, hits the orchestrator R and CD, and then we have a ArgoDB. But the next time a developer now needs a ArgoDB and the matching criteria are hit, a ArgoDB is there, right? And so that's actually what I want to double down a little bit more. That platform engineering is about structuring repositories. A good setup, right, has a different repository structure than a lot of the repository structures that we've been used to. So, and if I'm saying developer owned or platform engineering owned, I'm not saying that this is mandatory. And I'm not saying that sometimes there are developers that have both roles. That really depends on the compliance and security posture of your respective organization, right? So I was just in London yesterday with a large bank, and at that large bank, the division would be very extreme. It's not in the realm of possibilities that a developer is allowed to change the respective configurations of an S3 bucket in production. But that's just not going to happen. But let's say you are in a less security heavy environment, then you could absolutely say, hey, as a developer, you can maybe change everything globally until you get into pre-prod, and you can actually send a pull request to the global configuration of an S3 bucket. But what's different, and let's actually have a look at this, is that we do separate these things out. So the developer actually now primarily owns the workload. You have the work in every workload repository. You have the workload source code. You have a workload specification file. You have your Docker file. You have your pipeline YAML. And then you have the things that are cross-cutting across the organization. And the first thing that I want to look at with you, again, is the workload profile here in the middle. And you can think of the workload profile, I said that before, like an empty Helm chart, and it contains the things we need to create the application configurations. That could be CPU minimum allocation, labels and annotations, maybe the fact that HashiCorp Vault should start up as a sidecar, all of these things. Now, workload profiles have a one-on-one relationship with a workload, but no, it's not one-on-one, it's one-to-many. So one workload can actually, workload profile can be used in many different workloads. Because in reality, and I can tell you that firsthand, even if you're a very large organization, you maybe need 3, 4, 5 different workload profiles. That is pretty much it. Now then we have the way that resources are created. And that again, or wired. And that again differentiates static, so resources that you don't want to have lifecycle owned by the platform. They are just referenced. So you can register them and say, hey, by the way, we have this Postgres, it's already there. If somebody hits those criteria, please route. And then you have dynamic resources. And those are resources that if somebody needs an S3 and it needs to be spun up, please use this template. So this would be usually infrastructure as code. The difference is you now don't have, I was at this absurd case today where they had 470 different ways of creating Postgres across all teams. And you can say, why not? But you can also say, like, why would that be a good idea? There are no, it doesn't make sense. There are not, you don't need 470 different ways to instantiate Postgres. That's just not necessary. Like, you maybe need a couple. And so that's what you would actually have here. And then you have resource definitions. And resource definitions, there's a Terraform provider for an orchestrator, for instance, that says, if the env ID is staging and the app ID is ABC, then please use the following resource drivers. And the last thing are certain automations, compliance elements, and all of these things. And that's it. And so if you want to have that case, a ArgoDB, well, what you actually do is that you go into the Terraform provider for the orchestrator. And by the way, we can do that together. It's a fun exercise. So this is the provider. You go into the Terraform provider, you go into the documentation, boom, and we read this documentation from the bottom. Yeah, this is actually a terrible example. Let's look at this. So you say, well, this one here. Okay, so you say, if the criteria app ID equals test app, and the user wants a Postgres, then I want you to use the following resource definition, period, that's it, right? Or let's take another example. If env type is staging and app ID is test app and env type is development and app ID is test app, then please, at the request of GKE, use this resource definition. That's it. It's not super complicated. So that means in that case, right, where we want to train the system how to create a RungoDB, what that train the system actually means is you are extending that central logic on when to use what. Cool. All right. So now, you know, I bombarded you with stuff. I'm sure you're completely overwhelmed. If you want to be even more overwhelmed, then you can read the white paper on this. That is, there's one coming out on McKinsey.com, and I wrote another one that you know, that adds more of these things in. It's a little more, you know, detailed, 36 pages. So if you're at home with your partner and you really want to have a great thing to read at night, 36 pages of juicy platform content, definitely cool. And the packaged version is ready. It's coming hopefully soon. There is no tutorials, so it's extremely hard to use for you. But I'm hoping some of these guys can write tutorials, and otherwise I hope somebody else does it, or I'll do it. And then you can actually try these things yourself and you know, wire everything up and package this. Cool. And then, you know, last comment, there are like a ton more coming. The GCP one is in development right now. And then I think next is Azure, and then either multi-cloud and then OpenShift. So yeah, pretty cool. All right. Are there questions?
There are. Let me start. Can you talk a bit about the tension between standardization by design and service ownership, more specifically with opinionated engineers? How do you ever settle on standard, observing the 80-20 rule? Other methods?
Damn, good question. Nice question. Yeah. So let me share a funny observation, okay? In teams that have rolled this out end to end, this or another version, you know, you were observing the following. There is always that base layer of engineers that say, not over my dead body, I do not want to have anything to do with this. The amount depends. So the amount of developers that have that attitude. So in financial services companies, the developers are already, you know, really used to have a very narrow compliance angle, which means, you know, every single Terraform file needs to be reviewed by a central team. That takes 30 to 40 days, and you have the choice of taking that approach here or waiting 30, 40 days. You know, and in those cases, 90-something% say, oh no, I'm not going to wait. Like, I will sacrifice the granularity for this. In other setups that are, you know, the hipster startup in Austin, they will be more likely to say in 80%, in 20% of the cases, you know what, I actually want to, I don't want to have this. I will, you know, I'm totally fine with running everything myself. And so what these teams do is that they say, you know what, you can totally run your own stuff. No problem. You can go off. There's a great example in Brazil. I don't think I'm allowed to use that, but there's a great example that have built a fantastic platform, and they're also giving talks about that. And in their case, 18% of their developers are not on this platform. And then the platform team says that's totally fine, but then you're just not getting the defaults. You're basically on your own. You don't only have service ownership, you only also have the infrastructure ownership. And if things go sideways, it's on you. This is not tested, not anything. And that actually works pretty well. And then you have that, it oscillates between 80 and 90% coverage of the platform, and the others are just, on their own. You can't satisfy everybody. I wouldn't even try.
True. Are you planning on adding support for AWS EKS?
Yes, right. Yeah, that's a good point. So what you actually need there, and I didn't include this because I didn't want to do too much mindfuck, like my Italian colleague always says. Because what you then actually do is you differentiate the delivery plane layer. You have one delivery plane stream for containers. So developer control plane and the interfaces remain the same because you don't want to confuse. And then you basically differentiate on the delivery layer. EKS is pretty simple because of its abstraction logic, like a step function easier than VMware, for instance. And so this reference architecture currently, if I am not mistaken, does not include that out of the box. But this serverless stuff is coming later this year, being included here.
Cool. Does this work with AWS Lambda and DynamoDB?
So on the resources themselves, DynamoDB, there is no restriction. So there is no resource that this cannot deal with. On the workload compute, there is currently the restriction on containerized Kubernetes, but again, Lambda is also coming later this year.
What about the dynamic infrastructure code security? That's the question.
Mm-hmm. That's a very important question. So, that's in a security-heavy environment, you wouldn't even trust an automated system by just to just go to production. You want to have still others, you want to run tests, and you want to have a second system basically proving the other one. So in those cases, you let the if something runs through, one common method would be, once the configuration files are created, you have them being tested by a second system. And only if that test passes, you allow the deployment to go through. So there are pre and post deployment hooks that stop this, and then let the, call the third-party API, let the test run, and then signal back once this is ready to go. So that's the answer here. In general, this is a step function more secure than a static setup, just because it is very complex to connect to a test database from, because there's, automated dependency injection and all of these things. So we've observed that security and compliance teams love this. I'll give you an example, a fun one. So for instance, if you're dynamically creating these things, you have an immutable proof because everything is running through one unit, and you can run a diff. So you can do an API call to say, what's the material immutable change between deployment A and deployment B? And it returns that and says like, hey, CPU allocation, you add an S3 bucket, whatever. And like do that in a plain static approach, GitOps across 40 different services, and your deployment has gone wrong and you need to debug that. That's sort of, I spend a lot of time of my life doing that.
So it is a threesome then, plus security teams,
exactly.
platforms and devs.
Yeah.
Next question. Regarding the repo structure, would you allow service owners to make changes to platform-owned cross-cutting assets, especially for the 20% in the 80-20 rule?
I would personally do that, yes. So there's a little bit of a trade-off because you risk having deviation of, so let me correct myself. The reality is that only a small base of your developer will actually do that. But for those, I would actually allow that. I would, for instance, say, well, if you've hit a certain seniority grade, you can totally do that. I would do that all the way. And then the answer really depends on your security posture. And I want to make sure that I don't generalize. If you're a bank, my advice is please don't do that. But even then, you can probably go to staging, right? But you then cut this at prod. I always think if you can, and now we're getting into that idea of inner source, which I'm personally a fan of. If you can get into a mindset where the entire organization as a team is working on that resource graph, that would be such an incredible, yeah, that's so cool, right? That's like the gold standard.
Cool. Can you provide some examples of industries that are struggling more than others in achieving autonomous deployment capabilities?
Yeah, so yeah, I can force rank them actually. So it's definitely financials, then it's gambling. In gambling, you need to make sure that nobody can influence the statistical probability of an outcome. So that needs to be very, very gated. It's telecommunication. It's obviously, government, all of the government agencies, the security heavy ones. So for them, it's very, very, very difficult. But those are the ones where, frankly, the introduction of such a platform is much, much easier. So getting your colleagues convinced that this is a great idea in every financial I've ever been to says, like, the app devs, the security team, everybody says, thank God. Even already, if you go into the direction of retail, for instance, would it make sense to them? Yeah, definitely. But they will be probably slower to adopt this. My assumption. If they have 2,000 developers, probably still, because it's just too complex to manage.
What would be a good strategy to start building a platform that uses this reference architecture? As in, what would be the plane one should focus on to start with?
Yeah, so, okay, so we worked on that reference architecture as a starting point, because then you can say, okay, let me spin this up super quick. It takes, the first time it took me like 30 minutes. Then the second time I did it drunk in 20 minutes. And so it's getting easier. Then at some point, you're just waiting for Terraform to instantiate. I would definitely use that as a starting point, because it sets itself up, half an hour investment. And then you have something that doesn't make sense for you, because great, you have a platform, but it's not wired up to your systems. It's not in your network. It doesn't use your CI pipeline. But then you have something that's actually concrete. And then you start porting bit by bit. First of all, you add your CI pipeline. Then you swap your image registry. Then you onboard your first application. And that makes it much, much more productized and less. I see so many teams that spend the first 24 months conceptually exploring things, or then starting with the UI layer. And you've just seen it, like starting with the UI layer. That's probably, I don't think that this is a good idea. Like, that's not where the ROI lies. So that's my recommendation. And that's why this was important to me, like giving you a first thing, and then you can throw everything up. Maybe you don't want to use score, but you have your own definition. Perfect. Well, then you use your own and swap that. But then UI level, you mean all important, right? Yeah. Which that doesn't mean that they're not important, right? But if there is this article, if you have a pane of glass on a pile of shit, you're observing a pile of shit. You first you have to clean the house first. Build the house and then the front door, not the other way around.
A great article. Let me find it while Kaspar is answering the next question. So John is asking if you're planning to write a book. I'm sure you are already, but
I have a colleague, Florian, who is saying that every 2 weeks that we should write a book. For now, I have unfortunately not the time, but that's definitely something that I would look at, especially giving ChatGPT. No, just kidding.
Yeah, ChatGPT is going to write a book. The IDP resource definition should be tested to prevent regression. Regression, supposing that is accessible for more teams. If yes, how can we achieve this?
Yeah, great. So because it's all code, right? You can run regression tests on this, and you can make sure that exactly those things are tested for. There's also one of the things that I'm currently interested in that it's just not ready, but is dry run functionality. So actually simulating what happens at a resource request, and then the second you have that, you can actually optimize your test suites against this.
Cool. Can I upload my existing design patterns and make it available in catalog for developers to spin in production?
Yeah, absolutely. So, so what you can do is that everything you see here, like everything that I showed as code, can be packaged as a template, shared on your portal. You clone this, and boom, off you go, and this, and then the orchestration can happen. So yes.
Cool. And elevator pitch, Kaspar, in 30 seconds. Why do I choose Humanitec IDP solution and not Port IDP?
So this is not a product pitch, so I won't go into too much detail. Those are two different things. Port is a portal. That's why it's called Port. And so that's a fantastic tool. I looked at this a couple of weeks ago. You can very much integrate this on this highest layer here that we're seeing right here. I hope they write an integration to this. So they're a competitor to Backstage. And so you can basically have that there, aggregate, and then take over from there. Also, Humanitec is not an IDP solution. Humanitec builds several different tools, some open, some closed, that other developers can use to build platforms. If you want to have an out-of-the-box internal developer platform, then you should use, if you can do that, Heroku or Vercel, fantastic tools. And I'm always warmly recommending, if that's possible, please use a platform as a service. It's like, if you don't have to maintain Kubernetes, please do not maintain it.
Amazing. And any last questions? Guys, I just shared the blog post that Kaspar referred to. It's written by Aaron Erickson, who built a platform at Salesforce, so you can check it out, and we'll also we can include it in the follow-up. But other than that, if nobody has any questions, Kaspar, few last words to close it up.
Few last words. If you are interested to chat about this, I always encourage you to reach out to me. I always say that, nobody does it. If you want to chat about these things or test this reference architecture, then ping me. It's kaspar@humanitec.com. We can this will be open sourced, and that is we're going to share my email. And this is open. This is going to be open source, and there will be tutorials and more reference architectures, and you'll see them everywhere. So give free feedback, critical feedback, and looking forward to speaking soon.
Do you want to take this one last question?
Yes, please.
So 1 minute.
Love questions.
Ricardo, there is a concept of software supply chain security. Is this reference architecture hack-proof, or how it integrates security tools like SNCC, Aqua to ensure integrity of artifacts?
Mm-hmm. So there again, we need to look at if we look at the software development lifecycle and something flows in and it's local, dev, staging, prod, then this has the concept of deployment pipelines baked in, or you can simulate that with setting up CI systems accordingly. And that allows you and because everything is code, so it comes from code, and it will become code. It's like ashes to ashes. It's code to code, right? It's sort of an extremely philosophical thing now that I'm thinking about it. Now you can actually say, okay, well, Nick, test this at this point, test this at this point. run tests in between. As soon as something hits a certain stage, then we are running this again. So all of those compliance and security things can be integrated. But Ricardo, that's exactly what I mean, right? On the security plane and on the logging and observability plane, we need a little more meat on the bone, I think.
Amazing. Cool. Thank you very much. We're going to share the slides and webinar replay with you tomorrow. And also once we release reference architecture, we'll also share that with you via email. So stay tuned. If you're not a part of the platform engineering Slack community, join in. If you are not, if you have not signed up for PlatformCon and shared the link before, also join in. We'll have a ton of great content and even in-person events in a couple of cities. So also stay tuned for opportunity to connect with.
And you can meet the legends, right, from McKinsey, the guys who built this. I think Stefan and Mark, they're going to speak there, and I think they're also doing events. And so, yeah, these guys are great.
Amazing. Cool. Thank you so much, Kaspar, and hope everyone have a great